This lesson focuses on using similar triangles and the proportions we previously discussed to find a missing area. So you'll be given two triangles, they're similar, and you'll have one known area and you'll have to find the other unknown area. Okay, so again, a similar triangle, if you had triangle ABC, that's this tilde symbol, which means similar. So triangle ABC is similar to triangle DEF, which means the angles that correspond are all equal, and the sides that correspond are proportional to each other. These are not identical triangles, they are similar, so it's like they're scales of each other. The example I want to do is the following. If you're given triangle ABC, and you know it's similar to triangle DEF, you're going to find the area of triangle ABC. So let's show you the diagram. Okay, below you'll want to draw this out. So you've got triangle ABC and triangle DEF. You can see DEF is slightly bigger than ABC. These triangles are similar. Please pause and draw this out. With everything drawn out, okay, another piece of info that you're going to be given, which I'm going to give you now, is we're trying to find the area of triangle ABC. So we're going to call that X. And you'd have to be given the area of triangle DEF, and it turns out that it's 54 centimeters squared. You're also going to be given that this side is 8 centimeters, and you're also given that this side's 12 centimeters. So with this setup, here's the steps to find the area of triangle ABC. Again, these are similar triangles, and we're going to use proportions. Okay, so first step is you're going to need to find a known ratio between triangles ABC and DEF. So if I investigate, I can see that AB is corresponding with DE, and we can see that the ratio there is 12/8. Okay, so let's write that out. The ratio from AB to DE is 12/8. If you want to reduce, talk about it in simplest terms. Sorry, I have that reversed. Did you guys catch that? It's not 12/8. AB has the 8. So it's as follows. You want to point that out. This is a critical step. If you make that mistake, your answers are going to come out odd. You'll probably find that the area of the smaller triangle later on would end up being bigger than 54, which doesn't make sense. So I naturally made this error, but at the same time, I'll point out that it's important to try and stay on top and make sure these things are accurate so that the final answer is indeed correct. Okay, so ratio AB over DE is 8/12, which we can reduce down to 2/3. Okay, here's the new step. We're going to find the square of the ratio. So we're going to take 2/3. Well, let's write this up first. We're going to find the square of the ratio. So if the ratio is 2/3, we're going to square both of these. Well, not both of these. We're going to square the numerator and denominator, so both of them, and it's effectively squaring the ratio. And we're going to get the following. 4, 2 squared is 4, 3 squared is 9. So that's 4/9. And why we do this is as follows. The ratio of the areas for these two triangles is equal to the ratio of the squares of the corresponding sides. So that's how it looks written out with just some language. Let's put it down mathematically. Okay, so the ratio of the areas. Well, let's go back to our areas. the areas were x for unknown and 54 centimeters squared for the known triangle. So their ratios would be what? It would be x over 54. Okay, so the ratio of the areas is equal, so equal, and it says to the ratio of the squares of the corresponding sides. Well, in step 2 we took the square of the ratios and we realized it was 4/9. So that 4/9 is what we set inside this proportion. And we've satisfied this fact that similar triangles have. It turns out that in similar triangles, the ratio of the areas is always equal to the ratio of the squares of the corresponding sides. And now we just need to move forward the step we saw before, and that's called cross multiplication. It's all right that we cross multiply. And we're ready to do it. So x will multiply 9, 54 will multiply 4, x times 9 is 9x, and 54 times 4 is 216. You can divide out 9. It cancels. You're left with x equals 24. And then you interpret, we said earlier that x was the unknown area of triangle ABC. So the area of triangle ABC is 24. And a lot of people will stop here, but again, go back and look at your diagram and get your units. We're dealing with centimeters, so an area would be centimeters squared. So the area is 24 centimeters squared. Okay, so you can see the steps are always the same. To recap, you'd be given two similar triangles. You'd have to have one area known and one unknown. And you're always in a position where you have two corresponding sides where the values are known, in this case 8 and 12 centimeters. And there were 3 steps. You go find that ratio and you're careful to properly label it, AB over DE, and to get the values correct, 8 over 12, which reduces to 2 over 3. You square that ratio and you get 4/9. The last step is you're equating the ratio C that you found here to the ratio of the areas. And then again, you're following proportions method of solving, which is to cross multiply. You divide and conquer, and you're able to find the area. That's it for now.